Here we are giving this example for x near 0. Local normalization gives e to the x approximated as 1 plus x. Using the graph, decide if the approximate is an over or under an estimate. And estimate to 1 decimal place magnitude of the error for this interval where x is between -1 and x is equal to 1. So here what we want to do first, we want to use the graph of e to the x and 1 plus x to see if the estimation 1 plus x is under estimate or over an estimate. So the true function is e to the x and the approximate function is 1 plus x. This is near x equal to 0. So I'm gonna graph these. This is just a rough graph. I'm gonna graph first e to the x. I'm gonna pass through the point y equal to 1. And then what I'm gonna do in here, I'm gonna graph 1 plus x, the approximate function. So here, what we notice is that the approximate function is lower than the true function. So what does that mean? It means just the approximation 1 plus x is an underestimate. It's gonna be overestimate when it's gonna be that line 1 plus x above the function. So in our example here, it's under an estimate. Now we want to find the error between 1 and -1. Again, this is just rough. So the error will be between the true function and the approximate function. And it's gonna be e to the x. And we can see the largest magnitude of the error is at 1, the furthest point from x equal to 0. So you want to find the error at that point. So again, the error is gonna be the true function minus the approximate function. And both are given in this example. And remember, the error is always positive or equal to 0 if there's no error. So the true ex, it's e, the true f of x is e to the x, but before that, remember, this is not at x equal to 0. This is not at x equal to 0. This is at x equal to 1. We want to find the largest error on the interval between -1 and 1. Therefore, x is 1. We can also find it at x minus 1, but remember to take the absolute value of the magnitude of the error. So this is the approximate function, 1 plus x, but we're gonna substitute x by 1. So e to the 1 here, this is equal to approximated as 2.718 and then -2, and this is gonna be equal to 0.718. Remember, this is an approximation, this is not equal.